Hello students, how are you? Yeah, I'm fine too. Today I'm going to make you learn that derivative of a function using first principle. So first we have to know that what is first principle rule. So I'm going to write here the first principle. Here actually in the first lesson I have taught you that the derivative sign is like this: dx of the function y as y equal to f of x. So I have written that. So now there is another form which is called first principle. So this thing is directly derivative, and now I am going to make you learn that and the form. So I am writing it, that is, sorry, limit h tends to 0, function what will be here and the function what will be here, and it will be divided by h. So y equal to f of x. So if we increase amount of h, then it will be function of x plus h, and our function is here y equal to f of x. So here f of x plus h minus f of x. So our derivative sign, and here it is the first principle rule, both are equal. So from this to that there is proof. I will let you know later on. So now what I'm gonna doing, that is I'm just going to make some math on that topics today. So I will show you that some sort of function like y equal to x to the power n, it is algebraic. Then y equal to sine x, cos x, cot x, tan x, sec x, and lastly cosec x, and then another one ln x, a to the power x, blah blah blah. So from that, two of that I will do one, and from two of that I will do another one, and from two of that I will do another one, and this is the basic thing I will do definitely. So now I am going to show you the first thing for x to the power n. So I am going to watch it. Wait, hold on. So I'm going to make you learn today the y equal to x to the power n, how it is done by first principle. Okay. At first I'm writing the formula corner dx of y equal to limit h tends to 0, function of x plus h minus f of x divided by h. We'll maintain this formula. So here our function is y equal to x to the power n. So literally in the previous class we taught you that if we find out the derivative of x to the power n, it will, the answer is nx n to the power minus 1. Now we are going to do it by this formula. Okay, going to by this formula. So here if it is y equal to x to the power n, ultimately it is, what is it, as it is expressed by x, that's why it will be f of x. So by increment of h, it can be written as x plus h whole to the power n. So our formula was ddx of x to the power n. So we can write, it is very easy math. So here limit h tends to 0 and then the increment of h, what was it? This is, so I am writing this x plus h whole to the power n minus, and our function is x to the power n, so x to the power n divided by h. So now what can we do? Limit h tends to 0. Now we'll take common x, so it will be x to the power n, and it will be 1 plus h by x whole to the power n. I hope you all have understood that. If nobody has understood that, you might ask me in the comment box. I will answer it. Okay, now here it is h, so we are getting x to the power n and x to the power n. We will take common, so limit h tends to 0, x to the power n 1 plus h by x whole to the power n, 1 h. So now here I think all of you have passed as 9 and 10. There you have there we studied that the binomial, and now we'll use binomial theorem, because 1 plus h by x, I think, and just I'm getting some sort of reminder that a plus x whole to the power n, you have all encountered it in the binomial chapter. So from now I'll use it. So I'm writing it's limit h tends to 0 and x to the power n, then 1 plus, I hope all of you have know this formula of binomial theorem. That's why I'm not explaining it, I'm just writing it. N plus n minus 1 2 factorial x square blah 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 blah, the higher terms, you might write that, the higher terms. Now here it is minus 1 h. Okay, now if I just washing the brackets, and 1 will be gone. Now what can we do? We might use our sorry, I have just made a mistake here. As it is h by x, so we have to write h by x. Here it will be h square by x square. So now we can take h as common, so I'm writing it limit h tends to 0, x to the power n, and h as common. So here we are getting n 1 by x, sorry, we can also take common as x, n minus 1 2 factorial, here it will be h by x, h. So now is the formation. Now we will as here h tends to 0, so if we put that, then what will be, and one thing, h and h will be cut. I'm just a little space, so I'm just going to duster it. So I'm just writing here limit h tends to 0 x to the power n, so we can write x to the power n minus 1. And if we put just one thing I want to mention you, just to look at that place here, there is no h. So if we put the value that here, now all the terms will gone, so all the terms will be 0. From here all the terms will be 0. So x to the power n minus 1 into, as we have put that, if we put that in that place, then what will be? So our result will be x to the power n minus 1, and n will be multiplied, so n x to the power n minus 1. So dear students, all have, I hope all you have understood. And previously I have said that the derivative of x to the power n is n x n minus 1 from the formula. But this is the formula, this is the first principle by how we are getting n x to the power n minus 1. So that is the end of this math. So now I'm going to do another math. The function is y equal to sin x. So I'm writing it. So I'm going to write y equal to sin x. So it is a function of x. So if we increase amount h, then x plus h, then it will be sin x plus h. So limit okay, just a minute. We have to find out the derivative of sin x. Okay, so we are going to write ddx of sin x equal to, by the first principle, h tends to 0, sin of x plus h minus sin x h. So now sin of x plus h. Okay, I want to make sure one thing, that now I am going to make you learn that what will we use here. It's a trigonometric function and the trigonometric formula. I hope you all have all know the formula. It is written on the book, any book you can find it, but I hope I will write it down here later on. So limit h tends to 0, sin c, I'm just writing it shortly, sin c minus sin d to cos c plus d by 2 sin c plus minus d by 2. So that is our formula. Now it is c and it is d, assume it. So I am going to apply this. So what it will be, sin x plus h plus x divided by 2, sorry, here it will be cos and then it will be sin, as it is minus, at the first term will be cos. Now sin x plus h minus x divided by 2 and h. I hope all you have understood. Just I have used the formula. Now limit h tends to 0 and x will be cut off, and then I am keeping it here. So we can write h by 2. If it is shuffled, it will go there, you all know that. Then cos twice x, I'm just going to write it here, twice x plus h by 2. So the answer will be x plus h by 2. So I'm going to write it x plus h by 2, and here it will be sin h by 2. So now we have to make use another formula. Okay, so all know that I'm writing here formula limit theta tends to 0 sine theta divided by theta equal to 1. This is another formula for the limit. Just for the time, just see it that it has to be used. Okay, later on we will discuss it. Okay, so here it is theta and here the same thing theta. So if we write sine A, here will be A. If we write sine 2A, here will be 2A. Then the answer will come 1. Okay, now here it is, here h by 2, h by 2. So now we are going to apply this formula. So what it will be? Limit h tends to 0 cos x plus h by 2, and I'm just splitting, I'm using limit for that and that. So I'm just separating both the things. So limit h tends to 0. Now as here I have to make a quotation. That if h tends to 0, then we can write h by 2 tends to 0. So limit h by 2 tends to 0. So limit sine h by 2, h by 2. So now look on that. The value of that is 1. So limit h tends to 0 cos x plus h by 2 in here and the 1. Okay, I'm just brushing it. So from here, now we will put the value of h tends to 0. We will use here in the function. So it will be, if it is 0, then the term will be 0. So it will be cos x. So ultimately we are getting the result as cos x. So students, we know that if we find out the derivative of sin x, then it will be cos x. So we have already found that cos x. So our result is correct. Okay, I'm writing another math about y equal to tan x. Okay, and the formula y equal to tan x, and it's a trigonometric function already, and it is f of x. So if we make an increment of f of x of h equal to, it will be tan of x plus h. So from the formula we know that if we make the derivative of tan x, it will be, answer is sec square x. So we have to get by the first principle that sec square will definitely come, then we will be true. Okay, just I'm going to write d dx of tan x equal to, we can write limit h tends to 0 tan of x plus h minus tan x h. So what will we do now? We know tan equal to sine by cos. So we break it, limit h tends to 0 sine x plus h cos x plus h, here minus sine x divided by cos x divided by h. So now we will make it LCM. Limit h tends to 0, sine of x plus h cos x minus sine x, then cos of x plus h, and then cos of x plus h and cos x divided by h. So now here you can see also now we will use a formula like sine of a minus b. Sine of a minus b equal to sine a cos b minus cos a sine b. So sine a cos b minus cos a sine b. I am using this formula. So we can write sine of a minus b. So what is a here? X plus h, and b is x. So as it is minus, so it will be minus x, sine of a minus b. And here cos of x plus h divided cos x h. So now x will be cut down. Limit h tends to 0, and we can write sine h divided by cos of x plus h cos x and h. So students, just focus on that. Now I will use and the formula sine h by h. Here it is h, another h. So I am splitting now. Limit h tends to 0, 1 divided by cos of x plus h cos x. Limit h tends to 0, sine h by h. As it is h, so I am just not changing. Last time it was h by 2, that's why I have written here h by 2. So it will be 1. So now I am using that limit h tends to 0. So if it is 0, then it will be 1 by cos x plus 0, so it will be cos x, and here another cos x is here, so 1 by cos square x, ultimately it will be sec square x. So we have already got our answer that it is sec square x. So that is our answer. So now I'm going to show you another form, sec x or cosec x. From both of that I will do another one. Okay, I'm just wiping it. Okay, now I'm going to write y equal to sec x. So it is a function of x. So if it is f of x plus h, then we can write sec of x plus h. So now ddx of sec x, from the formula we know if we make the derivative of sec x, it will be sec x tan x. So we have to get this answer by first principle. Okay, so ddx of sec x equal to, you can write limit h tends to 0 and sec of x plus h minus sec x h. So again sec equal to what? 1 by cos. So we'll write there 1 by cos x plus h minus 1 by cos x, and here it is h. So limit h tends to 0. So cos x, I'm making LCM, cos of x plus h divided by cos x plus h, cos x, so it will go the lower part. So cos of x plus h cos x. So now I'm going to use another trigonometric formula, like it is cos d and it is cos c. Suppose x plus h equal to c and x equal to d. So the formula will be cos d minus cos c. So what it will be, limit h tends to 0 to sine x plus h minus x by 2 sine x plus h, so here is plus h cos of x plus h cos x. So actually the formula was like this: cos c minus cos d equal to 2 sine c plus d by 2 sine c minus d by 2. Here there is a minus, but as d cos d is in front, so the minus was uprooted. So now x will be cut, and now I'm just wiping the shortage of place basically. However, so we will write here limit h tends to 0, and here we're getting 2 sine x plus h by 2 sine h by 2 it is h cos x plus h cos x. As these two will come here, so try 2. I'm just so now again we will use another formula. Previous we have done already, h by 2 h by 2. So now we will split it up. Okay, now we will split it. So what we have to write here, limit h tends to 0 sine x plus h by 2 cos x plus h cos x, and then limit h by 2 tends to 0 sine h by 2 h by 2. What is h tends to 0? H by 2 tends to 0. So here the answer will be 1. So we can write limit, this part we will write here. So if we use h tends to 0 on that expression, so here we will find that sin x, I just make a gap, one line. So here h is 0, so cos x cos x. So sin by cos equal to tan x, 1 by cos equal to sec x. So arranging sec x tan x, here is our final answer, sec x tan x. So I'm wiping all those parts. I think all of you have understood the class. I have I have described all the formulas that from where it is coming. Okay, so now I'm going to do the ln x or a to the power x. Till then, just watch. Now we are going to learn that three maths: ln x, a to the power x, and log base ex. And if we expand it, log base ex equal to, we might write that. And I have written some series which will be needed further. That is ln of 1 plus x. The series, if we expand it, it will be like this, and a to the power for a to the power x, the series is like this. So now I am going to the first number 1. So dy by dx equal to limit h tends to 0. I'm do it a little bit precisely. So function of, I'm just writing the formula of first principle h. Then we might write limit h tends to 0, and function of x plus h is equal to ln of x plus h minus ln x divided by h. So here we can write limit h tends to 0 and ln x plus h by x h. How it will be, how it has, because we know a formula ln b equal to ln a by b. So now we can write limit h tends to 0 ln 1 plus h by x divided by h, then equal to, now we will use this series here 1 plus x, here 1 plus something. So instead of x we will use h by x. So limit h tends to 0, at first it will be h by x minus h by x whole square by 2 plus h by x whole cube by 3 plus minus dot 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 and divided by h. So now limit h tends to 0. If we here take h as, here what are these? These are the higher terms. So if we take h as common, then h and h will be cut. So we are taking common. So 1 by x minus h by 2x square plus h square by 3x cube plus minus dot dot dot. So now this h and h will be cut, and now we will use h tends to 0. So if we use h tends to 0, what it will be? In this term there is no h, so all the higher terms will be 0. So we will get our result 1 by x. As we know, as we have done previously, that ddx of ln x equal to 1 by x, and the result, it has come here 1 by x, so our result is true. And so we will go into the next math. So it is a to the power x. I am just pushing it. So here, one thing I want to say before going to number 2, I want to discuss about number 3, because both of them are very much similar. So I want to discuss about that. Here, one thing, if we expand the meaning of log base ex, it will be log base ae into ln x. So in the previous math we have done about the the first principle of ln x. So it's a, what is that? It is a constant. So as it is a constant, so it will go outside, so it will not affect our mainstream math. So we'll just just do the math for only for ln x. So we will get our answer 1 by x log base a e, and if we normally derivative the ddx of log base ex, we will get this answer. And in the first principle method we also get this answer, as ln x equal to 1 by x and log base a is constant, so we will get the answer. So I'm not doing the number 3 homework for you, but to the for the students, you might do that in the home. Okay. So now I'm going for number 2. So here number 2, I'm writing it up, our function. So I'm writing y equal to f of x equal to a to the power x. So f of x plus h equal to a to the power x plus h. So our rule was dy dx equal to the limit h tends to 0 f of x plus h minus f of x divided by h. So now f of x plus h equal to, we will just substitute the results, a to the power x plus h minus a to the power x divided by h. You can write now limit h tends to 0 and a to the power x dot a to h. If we split that, a to the power x into a to the power h, so minus a to the power x divided by h. So now limit h tends to 0, a to the power x, we are taking the common, so a to the power h minus 1 divided by h. So now we'll use a series of what? We'll use the series of a to the power x. Here here it is a to the power x, and here it is a to the power h. So we have to substitute x by h. So we'll write the series now. So now we're going to write limit h tends to 0 a to the power x, and then 1 plus h ln a divided by factorial 1 factorial h square ln a whole square by 2 factorial plus whole. So now the 1 and 1 will be gone, and later I'm just not writing the second line. After that I'm just 1 on will be cut, and we will take h as common. So we will get a limit h tends to 0 a to the power x, h as common, and it will be ln a by 1 factorial plus h ln h ln a whole square by 2 factorial h. So h will be gone. So limit h tends to 0. If we put h tends to 0 in for whole the term, then we might see that in this case there is no h. So from here all the term will be gone. So we can write a to the power x into ln a by 1 factorial equal to a to the power x ln a. So this is our required formula and it is our answer. If we make the differentiation of a to the power x, and it will be a to the power x ln a. So we have found that and it is our result. So we want to conclude here that it is the I have done the theories for the first principle method, the regular things. What is the rule we are encountering previously as we are using it like formulas. We have seen that the results are true by the formula of first principle. So later in the next video I will show you some maths like you have learned sine x. We will discuss about in the later on sine 3x, sine 5x, sine twice x, blah blah blah. Okay, so I hope all you have understood. So do share. Thank you.